Hello viewers, welcome to another section of my tutorial, and I have a problem in AC theory, and it says a coil has resistance 10 ohm and inductance 0.1 henries connected across a 100 volts 50 Hz supply. Calculate the impedance of the coil. So this coil has both resistance and reactance, and the reactive part is an inductance. So first of all, we are to express the two impedances given here into the complex form, and after you add them to get our impedance of the coil. So let's see, resistance is always represented as the raw part of the complex number. So we have our R. So let me write solution. We have our R to be equal to, that is 10 plus 0 J. So that is for the resistance, 10 plus 0 J, all ohms. Now they give us inductance, so you have to find the inductive reactance, that is XL. Now XL is given by 2 pi FL, where L is the inductance and F is the frequency. In the question, we're given frequency as 50 Hz. So you're going to have 2 pi multiplying 50 multiplying 0.1. And what will this give us? We know that 2 pi is, we have pi to be 3.14. So this is going to give us 2 times 50 will give us 100. 100 times this will give us 10. So we're going to have 10 by pi. And we know that this is the same as 3.14 times 10, which is also equal to 31.4 ohms. So this is the inductive reactance, and inductive reactance is represented with a positive sign and as the complex part of the impedance. So this can also be represented as 0 plus 31.4 J or ohms. So when I add these two, I'm getting, since they are in series or they are from just a single coil, when I combine it, I'm going to get my Z to be equal to 10 plus 0J plus 0 plus 31.4J, and it's giving me 10 plus 31.4J or ohms. So this is the impedance in the complex mode. So you have to find the magnitude of this complex number, and that will give us the actual impedance of the coil. So our Z is going to be the square root of 10 squared plus 31.4 squared. And what would that give us? You punch this into the calculator, and that will give you the final answer. So you get 32, Z is equal to 32.95 ohms as the impedance of the coil. Now we have another question in this section, and it says the impedance Z, which is 6 minus 8J or J8 ohm, is expressed at a frequency of 50 Hz. Write down the corresponding expression at a frequency of 25 Hz. So from here, we know that if an impedance is in the complex mode, the complex part is either an inductive or capacitive, and when it's negative is capacitive, and when it's positive is inductive. So since it's negative, you can see that here is a capacitive reactance. So we know that resistance has nothing to do with frequency change. If frequency of the wave is changed, the resistance has nothing to do with that, and it will have no effect, since resistance is constant and it's not dependent on frequency. But there will be an effect on the capacitive reactance. So let's see how capacitive reactance is related to frequency. We know that capacitive reactance XC is equal to 1 over 2 pi FL. So having all these parameters constant except the frequency, we can see that XC is inversely proportional to frequency. So making an equation where I'll have my XC1 to be equal to K, that is introducing a constant of proportionality, K over F1, then XC2 to be equal to K over F2. I can equate the two K's, and I'm going to, so from here K is equal to XC1 F1, and here K is equal to XC2 F2. So from here XC1 F1 is equal to XC2 F2, but I need the value for XC2. That will be my final capacity reactance. So my XC2 will be equal to XC1 F1 over F2. So from here, what do I get? My XC2 becomes, my XC1 was given as 8. So I'll write my 8 times the frequency, that's the initial was 50 hertz. I'll multiply by 50 over the final frequency, which is 25, and I'll be getting 16. Now I found my capacitive reactance to be 16, the new capacitive reactance. Therefore, my new corresponding expression at the frequency of 25 is going to be 6, that is Z is equal to 6 minus 16 J all ohms. Thank you. This is the end of my video. Kindly subscribe and share.